We're going to start talking about Taylor series. So not necessarily the polynomial versions of it. Well, Taylor series, we're just going to call it Taylor series. I'm going to talk more about stuff you can do with the series with special series. Okay, so we learned that the Taylor series looks like this as a polynomial. We're going to start to write it out like this with the sigma notation. So that's really the big deal of a change from before. So we're going to start to emphasize the sigma notation there, which is the same thing as all of this. Okay, so let's go do the first example, which is just a recall, really. We've done a problem like this already. So find the Taylor series for f of x equals e to the 5x centered at 2. Give the first 4 non-zero terms and the general term here. Okay, so to find this, I need to find f of c. So f of 2, I need to find f prime of 2, f double prime of 2. I need to go all the way since the first 4 terms just up to the third derivative. Okay, 4 terms, third derivative, because don't forget about the constant one. So f of 2 is going to be e to the 10. F prime of x, so take the derivative of that, is going to be 5 e to the 5x. So f prime of 2 is going to be 5 e to the 10. F double prime of x is going to be 25 e to the 5x. So f double prime of 2 is going to be 25 e to the 10. I'm kind of squeezing it in there. That's supposed to be an equal sign. And then f triple prime, so it's going to give us our 1, 2, 3. This gives us our fourth term, which it wants 4, is going to be 125 e to the 5x. This is going to give me 125 e to the 10. Okay, so if I just plug everything in right here, I'm going to get e to the 10. I'll do it with a different color. So I'm going to get e to the 10 plus 5e to the 10 x minus 2 plus, the next one is going to be 25e to the 10 over 2 factorial x minus 2 squared plus my final term, my fourth term here is going to be 125 e to the 10 over 3 factorial x minus 2 to the third. So that is going to go ahead and give us our first 4 terms. Now the general term is going to be this guy right here. This is the general term. So going to kind of figure out what the heck is going on for all of these. So for our general term here, it keeps going up. The 5 keeps increasing. So we're going to have 5, then 25, then 125. And we're starting at 0, by the way. So we're going to have 5 to the n. That's going to cover my coefficients here. E to the 10, because that's not changing. And then we're going to get the x minus 2. So the only thing I really need to do right here is find what that is right there. After that, just x minus 2 to the n all over n factorial. So this is the general term. So first 4, and then the general term. So essentially, this is actually a little bit of a formula here. There are 3 special maclaurin series that you must know, and here they are. And so e to the x looks like this right here, just 1 plus x squared over 2 factorial. Again, we can go through this entire process to figure this one out, but they're just giving it to us. We do need to have these 3 memorized. And this is related to that one right there, because first off, we're centered at 2. So all we're doing is putting minus 2's there. So that's the difference between this and that. And I have e to the 5x, so the k value is going to be 5x. That's what changes that in front as well a little bit. Okay. Okay, so when you use a series, when can you use a series to substitute it into? Okay. So there's 2 things you got to check for. So you can do this when so you need to check for the center. Okay. And you need to find the function value at the center. This is what you need to check for. Okay, and that's what we're going to do first. So see if I can create a maclaurin series here. So for sine of x to this right here. So I need to check for the center. So for the center, are they both centered at 0? Yeah, they're both centered at 0. Why? Because this one says it's a maclaurin series, which means we're centered at 0. Okay, so they're both centered at 0. And then I need to find sine of 0, which is 0. Okay. And then sine of 2 times 0 plus pi over 3, which equals sine of pi over 3, which is root 3 over 2. So these are not equal. So no, you cannot. So no, we would have to create from scratch. So we can't use this series that we can memorize and translate it into this, unfortunately, because the two centers don't match, okay, when we're at 0. Unfortunately. But here's 2 examples where you can. So for this one right here, it says find the maclaurin series. So these are both centered at 0 because it says maclaurin series. And then sine of 0 is 0. Sine of 0 squared is 0. So 1 and 2 check out for this. Okay? So we can just substitute this in. So sine of x is equal to x minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus, and you get the idea right there. Okay? Sine of x squared is just changing all these into squareds. So we're going to x to the 6 over 3 factorial plus x to the 10 over 5 factorial. You get the idea from there. So this is going to equal, going from k equals 0. It doesn't matter, you could use k or n. Formula just uses k. So it's kind of where I'm spitting this out at. All it's going to change here is we're just going to change the x into an x squared. So we're going to get negative 1 to the k, and then we're going to get x to the, there should be no parentheses there. My bad. X to the 2 to the 2k plus 1 all over 2k plus 1 factorial. It kind of looks a little weird, but that's supposed to be x squared to the, and that's good enough right there. All right. So that's one way of doing it, is just doing a direct plug-in. And you can kind of see little points down here. So we can just do a direct plug-in. Or for this one over here, we can just take these series individually, because this series individually is actually right here. Okay. This series individually is actually also right there, except my x values are all negative. So that just becomes a minus. The odds are going to end up becoming a minus. And then I'm just going to divide it by 2. It's not that big of a deal here. Okay, so since e to the x is equal to 1 plus x squared over 2 factorial plus x to the third over 3 factorial, I think that's enough. E to the negative x. So this one we are doing a direct plug-in like this one, because centered at 0, plug in a 0, get the same value. Do the same thing, except we do minus x. This one's plus because of the negative x squared would change that into a positive. This can become minus x to the third over 3 factorial plus x to the fourth over 4 factorial. Okay, so if we're going to add these together, so e to the x plus e to the negative x, add them together, you would get 1 plus 1 is 2. X minus x is gone. You would get x squared and x squared, which is going to give you 2x squared over 2 factorial. X cubes are gone. This is going to give you 2x to the fourth over 4 factorial. Okay? Now, if we took those and now divided them by 2, we would get 1 plus x squared over 2 factorial plus x to the fourth over 4 factorial plus, and then that's really it. So this is really going to be what as a general term. General term here is going to be, so I'm going to get 1. Okay, so it's going to be x to the 2n because I'm only doing the even. So it's really kind of the same thing over here, all over, and then or I'm doing the evens for the factorials here. So everything's just doing the evens. So that's essentially what just happens there. And actually, this is hyperbolic trig, which we'll get to outside of the BC where we'll do hyperbolic trig and BC. So talk about that one later. But yes, that is our first day here on Taylor series and memorizing these guys right here and starting to manipulate.